Hibernate. In this lecture, we will talk about the Hibernate and how to generate the Hibernate mapping Java source code from Visual Paradigm. We focus on the Hibernate, so if you are not using the Java as a development language, you can skip this lecture and move on to the next lecture. First of all, we will introduce what is an Hibernate. Hibernate is an object-oriented framework. It's designed for Java. Java is an object-oriented language. The nature of object-oriented is each objects are interconnected between different objects. If you look at the database side, database is more tabular form with the relationship with other data set, which is also a tabular format. You can see the mismatch. The Java code, the object-oriented, is interconnected, focused on the Java. And the relational model is more on the data and the relationship. So you can see the mismatch. And this mismatch will cause the persistency of a Java object. It will be very challenging. Let's take an example. We have an inheritance class like this. The photo is a superclass, and the wildfire and the landscape is a subclass. And how we store this kind of structure in the relational database? To solve this problem, we need an object relational mapping, maybe in short called ORM. The object relational mapping is a tier that helps you to translate your objects in Java into the relational model, which you can save into the database. And the most famous object relational mapping framework in Java should be the Hibernate. It serves the purpose that to translate from object to relational data or from relational data back to the object form. The Hibernate is a part of the community of Red Hat projects. It is an open source project, so you can bundle the Hibernate library with your projects without extra cost. And the Visual Paradigm will help you to generate the Hibernate mapping. That is a lot of challenge of deciding the Hibernate. Then we move on to talk about the mapping between the object-oriented and the relational mapping. In this example, as this training course, we focus on the database design. So we start from the relational database, we start from the entity relationship diagram. In Visual Paradigm, you can generate the class diagram from the entity relationship diagram, and vice versa to keep synchronized. To generate is easy. Let's take a look at the steps, and then I will do the demonstrations to you. First, you right click on the entity relationship diagram and select synchronize to class diagram. Then you can select where you want to generate. You can generate to a new class diagram, or you can select an existing diagram to generate the class diagram. Optionally, you can skip some entity you don't want to generate to class diagrams. Of course, it's optional. And then you click OK. Click OK to generate the entity relationship diagram. Let me just show you how to generate the class diagram. Now I have the entity relationship diagram here. I can right click on the entity relationship diagram and select synchronize to class diagram. Then I click it. Now I can configure where I want to generate. If you already have some class diagrams in this project, you will see the list. This is a new one, so I just name it online photo album class diagram, things like that. And then I can generate. Okay. Then you will see the synchronize to class dialog box. I will walk you through later on. We just click OK. Then now you see it is the class diagram is generated. It's almost same as the entity relationship diagram. I will talk about the mapping in the rest of the lecture. Let's talk about the options you can change, you can configure while generate the mapping. First, you can select where to place the class and the class diagram. You have three options. One is you can same as the source model element. It depends on where the class, the ERD is placed. Then we place the class diagram next to it in the same parent. Or you can generate to the root, which is we don't suggest. Or you can select another model to generate. The model is something like a folder in the file system. Then you can put it in the model. It's also a good practice. You put the entity in one model. This focus on database, and another model focus on the class. So you can specify. The next option is you see a list of entity and column will be synchronized. On the left hand side is the table and the column name. You see photo have an ID, title, description, etc. And on the right hand side is the class. We will generate and the attribute. You can double click to change, say, I don't want to generate the title as an attribute. I want to generate to something else. You can say photo title, something like that in the attribute. The name you put here will direct impact to the code generated. If you say it to photo title, then when you generate the Java code, you will have to set photo title rather than set title. So use it with care. On the bottom, you can export the mapping into the Excel file. You may be very interesting why we export it. You export to the Excel file, and then you can change it in Excel in a very convenient tabular form. And then you import your change back. Then you can change all the mapping with your standard, like you put the underscore before the attribute name, etc. You can also enforce some numeric and decimal type to be generated by using the type mapping option. On the bottom of the dialog box, you see there's add a stereotype PK to the ID attribute. You can add a PK stereotype to the attribute in the class diagram if it is a primary key. It doesn't affect the code generator, it just affects the appearance. Then you can easy to see, oh, this attribute is the primary key in the database. Then you click OK to generate. We just showed you generate the class diagram, and the similar procedure can apply from class diagram to ERD. It depends on where you start. Some team start from the object model. You draw the class diagram first, generate to ERD. Some team will design the database first, or you have a legacy database which is running today, so you can reverse it to the ERD and then generate a class diagram. Regarding the reverse engineering, you can refer to the previous lecture in the same training course. Let's look at the mapping in detail, how it maps inside the visual paradigm. First, the object, the entity in the ERD will map to the class in the class diagram. And very straightforward, the column will map to the attribute in the class diagram. There are one option. If you don't want to generate the attribute for the database column, you can set the property by open the specification of the column and set synchronize the attribute to no. You have a different reason to have this option. Something like you have the column which is auto-calculated using the trigger. You don't want the class diagram have direct access to it, then this program will not access to this column. Then you can turn it off and you use your trigger to calculate. On the other way around, if you have attribute in class diagram, you don't want to generate to the column in the ERD, you can also set the persistable to no. Usually this is a kind of a transient attribute. You just use it to compute the value in a memory model. You don't want to save it. Then you can set it to no. Then we will not generate the column to you. We move to the relationship now. In ELD, we have the relationship. Then generate to the class diagram, we will have the association to correspond the relationship. The foreign key relationship in the ELD have different things, different relationship type. First, you have a one-to-many. Then when you generate to class diagram, you will have the 1 to 0 to many association. If you have a one-to-one relationship, it's straightforward. To the class diagram, that will be a one-to-one association. If you have a many-to-many relationship, we have an associated table in between. Then we will have the associated class, which represent the middle objects. Let's move on to a more advanced topic we talked about before: how to handle the inheritance, the generalization in the ELD. We have different strategy. First, you can use one table to store all the attributes in the hierarchy. In this example, we have a photo class as a superclass, and we have some attribute I color in red, and the wildlife and the landscape. You have a different types of attribute. The first strategy is to put all the column into the same, all the attribute into the same table. Then you see the Boolean, and we use the discriminator column to distinguish what this table row is representing in which object. You can imagine if you save the data to the database and you load back, the Hibernate need to know this row is representing a photo or a wildlife or a landscape, things like that. The second strategy is to have a table per subclass. Then you will got a very similar structure. You have a photo, wildlife, landscape class. Then you have a photo, wildlife, and landscape table. This can save a lot of space. You see, we don't redundant the column. But this strategy have one problem, is the performance. You can imagine when you load up the object, load up the row of data to the object, you need to query to more than one table, at least 2, to get the objects back. So the query time will be a little slower than the first strategy, but that saves a lot of space. The third one is a table per conquest class. It's similar to the one table per hierarchy, but it will only create the enough attribute. Like we have a photo, then you just have a photo column. Then the wildlife, we have the wildlife column plus its own the photo column plus its own column. The landscape, we have the photo column plus its own columns. And this is a quite good strategy. But if you have a very complicated hierarchy in your superclass subclass structure, this could cause a management problem. To configure the strategy is easy. You just right click on the superclass, the top of the organization structure, open the specification, and then you go to the ORM class detail. Then click on the subclasses and select which the strategy. Select the class and change the strategy to table per class hierarchy, table per subclass, or table per conquest class. And then you just apply and close the dialog. And then you're okay to exit the specification dialog box. Okay, now we move on to talk about how to generate the Hibernate code. To generate the Hibernate code, you just go to the Tools tab in the menu and select the Hibernate and click Generate Code. And then you select the output path for the generated source code. If you are using an IDE like Eclipse, it's easy. You're just pointing to the project file, and then you can configure different code generation options, and you can go to the database tab to configure the database option. And this is necessary because we're talking about we really will save the object to the database. So the database option is important. You select the DBMS we talk about in code generation and configure the database connections. Click OK, and then you click OK to generate the source code. After you generate, you will got a set of source code together with the Hibernate library. We will bundle the library for you, add to your projects. Then you can start coding. And from now on, you can just write the Java code without single SQL to save your object to the database or load it back. I don't want to make this lecture so long, so I don't demonstrate how to programming, but you can find a lot of resources in Visual Program websites about how to do the programming. It's easy and very intuitive. Let's summarize what we talk about in this lecture. I introduced the Hibernate, and it is an open source persistent tier that you can incorporate in your projects without adding any cost. How to map from ELD to the class diagram. I talk about the basic idea of the mapping and show you the relationship, how to handle from the foreign key to the association and different kind of inheritance strategy. And finally, I showed you to generate the database and the code.